Let us solve few problems from exercise 2C taken from a textbook. Prove that sine of 150 degree plus x plus sine of 150 degree minus x equal to cos x. Now when we see this looks like sine of a plus b. Separately it looks like sine of a plus b, and this separately it looks like sine of a minus b. But if we take this thing as a whole, it will be of the form sine of x plus y plus sine of x minus y, and we have seen that this is equal to 2 sine x cos y. And we have learned the trick as well. Trick to remember this was, whenever there is a plus sign and x plus y, x minus y, sine of x plus y, sine of x minus y, plus means profit, so sine of x cos y, so sine takes the first portion and cos y, so plus profit. So we have learned the trick also, so we can apply the formula, the whole formula as a whole, instead of applying part by part, sine of a plus b plus sine of a minus b, we can do it as a whole, sine of x plus y plus sine of x minus y, which will be equal to 2 sine x cos y. So taking the left hand side, this is sine of 150 degree plus x plus sine of 150 degree minus x. So applying this formula, this will be equal to, in place of x and y we have 150 degree and x, and here also in place of x minus y we have 150 degree minus x. So when we compare these two, this will be 2 sine of, instead of x here we have here 150 degree into cos of, instead of y we have here x. So now our right hand side is cos x. We have to prove that this will be equal to cos x. So for this to be equal to cos x, this must be equal to 1. That is 2 into sine of 150 must be equal to 1. So let us find what is the value of sine of 150 degree. So 150 degree may be written as 90 plus 60 degree into cos x. So we have learned that sine of pi by 2 plus theta is equal to, this is in the second quadrant, pi plus 2 plus theta, pi by 2 plus theta is in the second quadrant, and we know sine is positive in the second quadrant, so the sign will be plus. But also we know that whenever it is a odd multiple of pi by 2, then sign changes to cos, so it will be cos theta. So we apply this rule over here, so this is 2 into sine of, this will be cos of 60, using this cos of 60 degree cos of x. So we put the value of cos 60 degree, which is equal to 1 by 2 into cos x. So 2 and 2 gets cancelled, so this is equal to cos x, which is the right hand side. So we have proved it. So we have applied here two results which we have learned. So in this way, when we remember the result very clearly, then automatically it comes in our mind what formula to use. So before solving the problems, we must be clear with the formula. We must well memorize all the formula and the results. Now let us see next problem. Sine of x minus pi by 6 plus cos of x minus pi by 3 equal to root 3 sine x. We have to prove this. Now we see here whether we can apply the formula or not. Here we see this is of the form sine of a minus b and plus cos of a minus b. Now we see whether we can apply any of this formula. We don't have a formula sine cos in between. So also here y is not the same. So even though it is sine x, sine of something plus cos of something, but here y is not the same, so we have to apply separately. Sine of a minus b and cos of a minus b has to be solved separately, so we can not combine the formula here. So left hand side is equal to sine of, so apply the formula sine of a minus b, which is sine a cos b minus cos a sine b, plus cos of a minus b is cos a cos b plus sine a sine b. So next is we put the values. Sine of x remains sine of x. Cos of pi by 6 means pi by 6 is 30 degree. So cos of pi by 6 is root 3 by 2. And again cos of x, sine pi by 6, again it is 30 degree. Sine pi by 6 is 1 by 2 plus cos of x remains. Cos pi by 3 means cos of 60 degree is 1 by 2 plus sine x, and sine pi by 3 means sine 60 degree, which is root 3 by 2. So again we have to now simplify it further. Root 3 by 2 sine x minus, here we see, again let us write it nicely, cos x by 2 plus cos x by 2 plus root 3 by 2 sine x. Now we see it is minus cos x by 2 plus cos x by 2. This is 0. And we see these two are again the same. So when we add two same things, it will become twice of that thing. So when we add this and this, these are same. So adding two same things means 2 times of that. So 2 and 2 gets cancelled. So what we get? Root 3 sine x. So we want to prove root 3 sine x as in the right hand side. So we got it to be equal. So it is proved. Next question is express each of the following as a product. Here we are given sum of two sine functions, that is sine of 10x plus sine of 6x, and we know that we know the formula sine x plus sine y is equal to, whenever sine is having plus, then twice of sine of x plus y by 2 cos of x minus y by 2. So we have seen whenever there is a plus, it means profit. So sine takes the bigger part and gives the smaller part to the cos. So we apply this formula here. So this will be equal to sine of 10x. Here instead of x we have 10x, and instead of y we have here 6x. So this will be equal to 2 into sine of x is here 10x, and y in place of y we have 6x divided by 2, and here cos of 10x minus 6x divided by 2. So this will be equal to 2 sine of 10x plus 6x is 16, and 16 divided by 2 will be 8x. And here again 10 minus 6 is 4, so 10x minus 6x is 4x. 4x divided by 2 is 2x. So we have got this as a product of sine and cos function. So we have expressed the sum as the product. So this is our answer. Next question is express as an algebraic sum of sines or cosines. So we are given the product of two functions. So sine 6x into cos 4x. Now this is product. We have to express this as sum. So again we have seen the formula 2 sine x cos y is equal to sine of x plus y plus sine of x minus y. So we can apply this formula here. So 2 sine x cos y. So this will be equal to, here sine of x plus y means 6x plus 4x and plus sine of x minus y means here in place of x we have 6x, in place of y we have 4x, so 6x minus 4x. So this is equal to sine of 10x plus sine of 2x. So we have expressed as the sum of sines. So our product we have expressed as sum.